So now let's look at conditional probability. So let me erase some of this. I'll keep the charts, and I want to erase the rest of this. Okay, so let's now look at conditional probability. So the definition of conditional probability is probability of it's probability of A given B is equal probability of A and B divided by the probability of B. So that's conditional probability. That's the formula. So more intuitively, conditional probability, what it is let's say we know that heads happen. We know that. So what's the probability? Let's look at independent events. We know that heads happen. We're here. We know that. We're already here. So what's the probability of rolling a 2 on a die? We know we're here. So that's what conditional probability. That's conditioned on us being at this note right here. Heads happen. And we know that the conditional probability of hitting the 2 is 1/6, because here we're just rolling a die. It's again, it is 1/6. So now let's just to use this formula, let's plug the numbers into this formula. So we get probability of 2 given that heads happen equals probability of heads and 2 happening divided by probability of heads happening. Probability of heads and 2 happening is 1/12. We divide this by probability of heads happening, that is 1/2. Again, 1/6. Again, for independent events, the conditional probability is equal to just probability of rolling a die and getting a 2. Again, it's the same. It's 1/6. Now let's look at dependent events. Okay, yeah, we can use this formula. We will use this formula, but let's say we want to look at the condition that somebody is in South America. What is the probability that they're following the event? So if we know they're in South America, what's the probability that they are following the event? So we know they're here. What's the probability they're following an event? It is, given those numbers, it is pretty easy. We know that. We know that this is 90% because we know we're here. And we know that 90% of South Americans are following Copa America. But let's suppose we didn't have this number. We only had this and that. Then we could calculate the conditional probability. Probability of somebody following the event, given that they are in South America, equals probability of them being in South America and following the event. Probability of somebody being in South America and following the event is this number is 0.045. This number is 0.05. And if we divide 0.45 by 0.045, we get 0.9. So this formula could be useful if we just weren't given this number. So that's the conditional probability. So the last thing I want to talk to is Bayes' rule. So let me erase all this stuff and talk about Bayes' rule. So Bayes' rule is useful. Let's say I told you that I have a friend who is following. I have a friend and he's following Copa America. That's all you know about my friend. Using this, you could try to figure out whether my friend is from South America or Western Europe. You only know that my friend is following Copa America, and you know all those probabilities. So I'll get back to this, but just want to see like Bayes' rule for independent events. Let's say I told you that I rolled a 2. What does it tell you about what happened on a coin toss? Basically nothing. We know that there's still there's a 50% chance that there were heads happened before or tails happened before. So you can plug it into the formula and verify that the Bayes' rule actually does work for independent events too, but it's not that helpful because we can already see what's going to happen. It's really easy to see intuitive, and that's what's good about independent events. Okay, now I'm just going to erase all of this because we're done with independent events for this lecture, and we're just going to focus on how we can use Bayes' rule to find the probability of whether a friend of mine that you know is following the Copa America is from South America, or what's the probability that my friend is from South America. Okay, so Bayes' rule, the general formula for Bayes' rule is I'm just setting up a general tree. So the specific one here, there's a general one, and I'm going to give you the formula in general terms, and then we'll use our numbers and plug those numbers into the general formula and get our answer. So if we know that B happened, what's the probability of A? So this is what this formula is trying to answer. Like we know that my friend's following the event, but we want to know what's the probability of that my friend's from South America, which is that is actually A in this case. So this is probability of. Well, let me just rewrite the formula in our terms. So I want to know that what's the probability that my friend is from South America, given that my friend's following the event. So this is this one. So what is the now to answer this question we need to know the probability that. The probability of what's the probability that my friend is following the event, given that my friend is from South America, times the probability that a person is in South America, and divided by the probability that a person is following the event. what's this number? What's the probability that a person in South America, we know that they're in South America, is following the event? So we know they're here. So this probability, this number is going to be 0.9. Because we already know that they're in South America. So this part is 0.9. So it's 0.9 times probability of being in South America is 0.5, which is nothing. So what's the probability of a person following the event? What's this? So remember we calculated this number when we did the marginal probabilities. So this is what it is. The marginal probability of somebody following the event. This is, so let's do it again. So this is equal to probability that somebody is in Western Europe and they're following the event, plus the probability that they are in South America and they're following the event. And that sums up to 0.65, or 65%. So, and that equals to 0.69 so that's the answer. So if we know that my friend is following Copa America, so given this little world of just two regions, we know that there's a probability of 69.23% that they are in South America. So that's how Bayes' rule helps us. So in summary, today we introduced some basic definitions, then we looked at independent and dependent variables, dependent and independent events. We saw how it is much easier to work with independent events, but we got some pretty cool formulas like Bayes' rule to work with dependent events. So I hope it was helpful. So thank you.